So from AP1-1 on page 94 plus a little bit, number 6, piecewise defined function on 3 different intervals, ax squared plus x minus b when x is less than or equal to 2, ax plus b between 2 and 5, and then lastly 2ax minus 7 when x is greater than or equal to 5. So piecewise defined function. Left of 2, we're using this quadratic. Between 2 and 5, we've got a line, and when x is greater than 5, we've got a different line. Part A, find the values of a and b such that f is continuous everywhere. Okay, well, less than 2, that's a parabola that's continuous. Between 2 and 5, that's a line that's continuous. Greater than 5, that's a line that's continuous. So the only places I'm really, really worried about are 2 and 5. Because that's where it makes, I don't want to say jump because that's not the technical term, but that's where it changes from one function to another, and so there might be a jump at 2 and at 5. So at 2, I need to make sure that this piece, I'm just going to label them, I was going to label them A, B, and C, but we already have an A and a B. Part 1, Part 2, and Part 3. So at 2, I need Part 1 to equal Part 2. So that would be A times 2 squared plus 2 minus B equals, and then Part 2, A times 2 plus B. So let's clean that up a little bit. That's 4A plus 2 minus B equals 2A plus B. I don't know how we want to do this. Move the 2A's over. Plus 2. Move the B over, I guess. And then I could divide it all by 2. So A plus 1 equals B. That's, I guess, helpful, but not ultimately helpful because there's still 2 unknowns in there. I still don't know what A or B are. So let's go back to 5. When x is 5, part 2 of the equation should equal part 3 of the equation. So part 2 at 5, when x is 5, that would be 5a plus b. And then when x is greater than 5, part 3 would be 2 times a times 5 minus 7. So 5a plus b equals 10a minus 7. Let's see. So I have 2 equations with 2 unknowns. So however you want to solve that using your Algebra 1 and Algebra 2 skills. I sort of lucked into having them both equal to b, so that might be the easiest way to go, is just say a plus 1 equals 5a minus 7. Transitive property, if this equals this, but b equals this, then those two are equal to each other. So a equals 2, and then a plus 1 equals b, so b equals 3. So a lot of work for part A. I mean, a lot of work, but not a lot of calculus, really. Just recognizing that at 2 and at 5, the equations have to equal each other to make it continuous. Part B. Limit as x approaches 3 of f of x. Well, if it's continuous, then I can just use substitution. I don't have to worry about holes or asymptotes or jumps or anything. So be careful, that's not always true, the statement that the limit equals the function. But if it's continuous, right, no matter how weird it looks, if it's continuous, then the limit and the function are the same. So f of 3, let's see, that would be on part 2 of the equation, which is ax plus b, which is 2x plus 3, because we know a and b now. And then at 3, so f of 3 is 2 times 3 plus 3. And if we really wanted the safe stop, we could box that up as our answer and be good. And then part C, g of x equals f of x over x minus 1. And we want the limit as x approaches 1 of f of x over x minus 1. Well, at 1, or I shouldn't say at 1, I should say close to 1, the f of x is the first, we'll use the first piece of the piecewise function, because 1 is less than 2. So anywhere close to 1, we'll be using ax squared plus x minus b. So that is the combination of x being close to 1 and f of x means I'll use this piece of the formula, or that piece of the function. Let's see, a is 2, b is 3. And I mean, I saw the problem at the very beginning. If I plug in 1, I get 0 in the bottom. So that really won't work yet. But if I factor the top, I bet one of the factors is x minus 1 to make this work. And yep, that works. So the x minus 1s will cancel. And then I can plug in 1. And I guess I could leave that as a final answer. 2 plus 3 is 5. So that's number 6.